recording here. Calc exam, yeah. All right, I think we're good to go. So, any questions up to where we are now? All right. Well, let's start off by looking at PA1 in some detail. And let me bring up. It's posted on Canvas. It's been posted on Canvas, but let me bring it up in here. All right, so we've been playing with classes. We made a rectangle class and so on. So for your assignment, you're going to make a fraction class, which implements rational numbers, right? Fractions. So basically, a new data type that can store a numerator and a denominator, representing a fraction. So, and this is something that actually is not like built into most languages, right? If you want 1 over 3, you can divide it and you get 0.33333, but it's not exact, right? So fractions are useful sometimes. So you're implementing a class named fraction. And I'm going to describe exactly what the interface should be like to the fraction class. In other words, what the constructor is, what the methods are that you can use to interact with it. But how you implement it is really up to you. Right? Remember, we have this notion of an abstract data type, right? So this is going to describe how somebody from a main program, for example, would interact with the fraction class. But what you do inside your code to implement this, that's totally up to you. Now, there's not a whole lot of wiggle room just because, multiplying two fractions, there really aren't, a million ways to do it. But the implementation, that's your creation. All right, so first of all, constructors. There's two ways to construct a fraction. One is by giving the constructor both a numerator and a denominator, the top and the bottom, right? The other way is to construct a fraction by just specifying the numerator and assuming that the number is numerator over 1. So, 15 is a fraction. It's 15/1, right? 15 over 1. And sometimes we'll want to make a fraction that's actually a whole number. So instead of saying 15 comma 1, we can just use a single argument, and that's the numerator. So that lets you experiment with signatures on constructors. All right. 4 main methods for combining fractions together: add, subtract, multiply, and divide. And the way this works is, for example, if x is a fraction, we can say x dot add, and we can use as an argument a second fraction, which I'm calling n. And this should create a third fraction, n plus n, and return that as the value of the method. And we're going to go through a bunch of sample code using these methods and constructors, so we'll get some specific details in a minute. So 4 ways to combine fractions: add, subtract, multiply, and divide. All right. These should be in reduced form. We'll talk about that later on, but basically if your answer is 6 over 2, you should reduce that to 3 over 1. If your answer is 36 over 15, you should reduce that to 9 over 5. Right, or 12 over 5, whatever that comes out to be. So you want your fractions to be reduced. There's also a method for converting a fraction to a double. It's called to-double. It doesn't take an argument. It's not, an arbitrary function that we pass a fraction and it gives us back a double. It's a method inside the fraction class. So if x is a fraction, we can say x dot to-double paren, and the return value of that method is a double precision number that's got the same value as the fraction, or approximately. All right, 2 accessors, one for getting the numerator, one for getting the denominator. And then a toString method, the usual public string, toString, no arguments, that returns a string that represents the fraction. So that if we try to print the fraction by concatenating it to a string, it'll look, something like what we would expect. Okay, those are the requirements. But you'll probably end up writing some more methods, and you can make these private. But, and it's up to you what you make. But for example, you may want a reduced method that takes the numerator and denominator and changes them around to put your fraction into some sort of normalized form, depending on what you consider to be normalized. But one thing, for example, would be to factor out any common denominator so that it's always in reduced form. Another thing is if the numerator and denominator are both negative, it might make more sense to make them both positive, because -1 over -3 is still just 1/3. And for converting these things to strings, the minus signs can get a little tricky, not too bad. All right, so you'll probably have other methods. Those can be marked private, and it's up to you what you want to do in those. All right, I recommend Euclid's algorithm for finding the greatest common divisor, and we'll go through that in a few minutes. If you weren't in 215 in fall, I don't think we did this in winter. So we'll go through Euclid's algorithm, but it's a really simple recursive algorithm for finding greatest common divisor. All right, division by 0. Since we have fractions, there's a possibility a numerator is 0. Since we have a divide method, there's a possibility we're going to try to divide by 0. In any of those cases, you don't want to blow up, okay? You just want to record internally that this thing is not a number, okay? So there's a thing called NaN, not a number. And once something is not a number, if you try to add, subtract, multiply, or divide anything with that, the result is not a number. Okay, it's kind of like it's you know, an ostracized number. So if you try to divide by 0, the result is NaN. And this shows up in 3 ways. Okay, number 1, if you use the 2-double method, it should return this thing, double.nan, and this is a valid expression in Java. If you have a function that's supposed to return a double and you return double uppercase D dot nan, little a, it's a valid double precision number. And if you try to print it out, it'll say nan, and if you try to combine it with things, it'll be nan. But it's a special binary pattern, 64 bits, that's reserved for saying this is not a number. So your 2-double method, if you've got a number that's invalid, should return that. Your 2-string method should return NaN. Okay, just as a string. And anytime you try to add, subtract, multiply, or divide, the result is automatically a fraction that's not a number. And how you code that's up to you. You can put a separate flag in your class. You know, as a private field, you can normalize and just look for a 0 in the denominator. It's totally your choice, okay? So the 2-string method, right, just make sure that what it prints out for the value of a fraction looks reasonable, not prints out. What it returns as a string looks reasonable, okay? For example, if your numerator is 1 and your denominator is -2, when you convert this to a string, it should be -1/2, not 1/-2. If both numerator and denominator are negative, the string should be 1/2, not -1/-2. So, you know, make these things look like fractions, like your elementary school teacher would like to see. And if you convert a number that's not a number to a string, you should return the string NaN. Or sodium nitrogen, I guess. All right, reducing numbers. Eliminate any common factor between the numerator and denominator. And then, you know, if you always keep the denominator non-negative, that's going to make life easy. If you always change 0 over anything to 0 over 1, that's going to make life easy. Okay, but that's up to you. As long as, you know, when you convert this thing to a string, it's coming out in reduced form, and it's not going to blow up, right? And so my suggestion is just always keep things in this reduced normalized form. All right, grading, super simple grading rubric here. So 90 points for how the class works, 10 points for the documentation and style. So if it works perfectly, right, if all the tests I try at it come back perfectly correct, 90 points on a 90, okay? If most functions work, but there's a few errors or glitches, it's 70. It's subjective. What do I mean by a few versus a lot? If I print a fraction and it's 1/-2 instead of -1/2, that's a minor issue, right? If I try to print, 1 over 0 and my program exits, that's a major issue. Okay, if things are not being put in simplest form, that's a major issue. So minor detail, 1 or 2 places, right, 70 points. If some functions work, but there's some that are unimplemented or not present, if you're not reducing to simplest form, if you don't have a toString method and so on, right, 50 points. If most of it's not working, but you've got, a constructor that works and something else that I can at least see you've got a few of the pieces in place, you might get 30 points. Less than that or not submitted, it's 0. And then documentation, so I need a header block in the beginning of the class, okay? And it's got to include your full name, the date, the name of this class, and your own synopsis of this class. And this has to be detailed. It's got to be a lot more than just, fraction class, a class for manipulating fractions. I need a lot of detail. I need enough detail so that if somebody who doesn't know anything about this course were to pick up your file, fraction.java, they could use it without having to reverse engineer the code. Okay, they could look at your description and they could say, oh, okay, here's how I add fractions, right? So insufficient detail that having never seen this class before, your description would completely explain it. Code has to be cleanly written, indented, logical variable names, etc., etc. Description of each method, and comments on any line that's not absolutely, completely, positively obvious why it's there, right? And in Java, Java is high level enough, we don't really have, 5 or 6 lines doing one thing. Usually one line is going to do something pretty significant, so you may have a comment on every single line, all right? So full comment block, good commenting, good style, 10 points out of 10. Header block present, but weaker commenting, 7 out of 10. Header block present, but very little commenting, 3 out of 10. No header block, 0 out of 10. Okay, pretty straightforward. All right, testing. Here's a sample main program. We're going to play with some more main programs in a minute. But here's a sample main program. And yeah, if you came in late, we're talking about PA1. Here's a sample main program that uses the fraction class. So I'm just calling this fraction test. It would be in a file, fractiontest.java. And so, for example, I'm making a fraction a, and I'm constructing it with the arguments 1 and 2, which means a is the fraction 1/2. I'm making b a fraction, which I'm constructing with just a 4. B is the fraction 4, or 4 over 1. C, D, and E are declared to be fractions, but I haven't given them values yet. Okay. Now, if I make a new fraction out of 125 and 50, and I concatenate that to 5/2 colon space, this should print out 5/2 colon 5/2. Okay, in other words, this is going to create a fraction. And then that fraction can be concatenated to a string that will call the toString method in this fraction, which should print out, or should return a string equal to 125 over 50, but in reduced form, so 5/2. I'm going to take A, I'm going to add B to it, that's a half plus 4. C should be equal to 4.5, which is 9/2. And down here, when I print C, it should print out 9/2. Here I'm taking a fraction 1, 2, so this is 1/2. And once I say new fraction 1, 2, that's a fraction, it has a multiply method. So I can call that multiply method, it needs a fraction as an argument. Here's the fraction I'm going to pass as the argument. It's fraction 2 over 1. So this is 1 over 2 times 2 over 1. This whole thing is a fraction. And it should be the fraction 1 over 1. And so when I concatenate that to a string, it should just print out a 1. And even though, we usually use temporary variables when we're doing multiple calculations, I want you to embrace what's going on right here, right, in this line. This is pretty powerful, right? We're constructing a fraction. Once we have a fraction, that has a multiply method, and we can invoke that by saying .mul. And a multiply method takes an argument, which is a fraction, and here we're creating a new fraction. And this whole thing is a fraction, which means it has a toString method, and we're calling this fraction's toString method because we're saying plus. and concatenating to a string. And you really want to kind of start breaking down the mental distinction between code and data, right? This thing, we can think of it as a number, 1/2, but it's also a class. It's an object, right? Which means it has methods, which means we can execute code inside this thing. It's more than just a number, 1/2, 0.5, right? It's a whole object. Let's see, on the first example, 125.50, how would the constructor return toString without calling it explicitly? So the constructor simply creates the fraction, and so this thing that's highlighted right here is a fraction, but the JVM, when it interprets this line of code, it says here's a string, I'm going to concatenate or append another string to it. Well, this is not a string, it's a fraction. I have to change it to a string, so I'm going to call this method's toString, this object's toString method. That's where the toString gets invoked. If we wanted to, we could put a .toString right after this parentheses, and that would convert this whole thing to a string, and then we'd simply be concatenating two strings. But it takes care of that for us automatically. All right, so we've got lots of things going on in here, lots of examples, right? So there's C, which is 9/2. Now we set C equal to A minus B, so that should be 1/2 minus 4, which would be 1/2 minus 8/2 is minus 7/2. And so when we print C, we should get a minus 7/2. And then if we do B minus A, that's 4 minus 1/2 is 3.5, so that'll print 7/2, and so on. Okay. Here we're doing C multiply C. C is a fraction. It has a multiply method. It expects a fraction as an argument. We're passing C as the argument. And if you think very deeply about things like this, it gets really kind of weird and confusing, right? And it's like recursion. Sometimes it's really good to think about it deeply. But in general, when we're actually using this, we're not thinking about it deeply. We're not thinking about how this is working. We just kind of get used to the fact that, like, yeah, this is C, I'm going to multiply it by C. This is a fraction equal to C squared. All right, so this goes on. There's division. There's more multiplication. Here's the 2-double method. So I'm going to create a fraction, which is 1/3. I'm going to call 2-double. This thing that's highlighted is now a double. That's like a double in C, right? And when I concatenate it to a string, the JVM will call the double's toString method effectively, not exactly. And this will return the string 0.33333. So that should be printed out after this part of the output. And then there's the not a numbers, right? So here's a fraction, 1 divided by 0. That should be not a number. And if I print it out by concatenating it to a string, it should just print NaN. Okay. Shouldn't print any other messages. There should be no warnings coming from your constructor saying division by 0 detected, right? It's a different kind of number. It prints out as NaN if we print it. So here A and B are equal to 1/2. C I set to A minus B. That makes C a 0. How is that stored internally? It's up to you. I would store it as 0/1. But, you know, sets it up as 0. Now I set A equal to A divided by C. Well, A was equal to 1 somewhere up here. Actually, A is equal to 1/2. But I divided by C. That should be not a number. So A should be a NaN. And if I convert it to a double, and I print that out, that should print out NaN. That's what happens when you have a double.nan and you convert it to a string. And then here I've got a 0/0 for A, and if I make that a double, that should be a NaN. And if I make a new fraction -1/0 and I convert that to a double, that should be a NaN. All right. Submission, make yourself a subdirectory under your CSE223 dir, make a subdirectory called PA1, put your project in there, okay? And then, you know, git add, git commit, git push, the usual drill. You don't need to do a git init. If you're in a subdirectory of your submission directory and your submission directory is already under git control, your subdirectories are under git control also. So you don't need to do a git init, you don't need to do a git remote add origin or any of that stuff. Just make a directory and start writing your code. And when you get to good stepping points, git add, git commit, git push. Okay? And make it a habit. Don't just develop your code for a week and then push it into Git at the last minute. Just start pushing it in there like as you go, right? Let's see, I got add submuldiv wrong first because I assumed we would add the fractions together by storing the result in the fraction whose method was called. Yeah, so I want to return a brand new fraction. Although that would be a legit way to do it too, but not for this. All right, so make your subdirectory PA1 and do your work in there. The only thing I'm looking for is fraction.java. Okay, but if you want to break this up into multiple classes, that's fine. But I need all the source code. Okay. If you know what packages are, don't use packages. If you don't know what packages are, don't worry about it. Right? If you know what packages are, stick with the default package. It's a better way to put it. If you don't do anything with packages, you don't know anything about packages, you'll be using the default package anyway, so you're all set. To compile your class, I'm just going to say javac fraction.java. If I need to do anything other than that to make your class file, give me a make file. Okay, so I'll do javac fraction.java. If that works, great. If it doesn't, I'll say make. If that works, great. If not, then it doesn't compile. Okay, if you just do one file and it's just fraction.java, this is going to work fine. But if you're going to get fancier and make separate classes and put them in separate files and so on, just leave me a make file. All right, and then I'll use my own main program. You can leave your main program in there if you want. I'll probably overwrite it. But you know, if you got test files or things like that, that's totally fine. Operator overloading. Yeah, I remember when Ada came out, people were so excited about operator overloading. Like this was going to change the world or something. It's a cool feature. It's nice in C++ because, you know, if you made a fraction class, you could add two fractions with a plus sign instead of, you know, fraction.add by calling a function. And that's really cool. You can fake it pretty easily, though, at least if you're living in a Linux world. I mean, you could make your own precompiler that would wire things up like this for you. And I'm sure that's already out there and available. You make Java++ or something. All right. So questions about this so far? I want to dig into some examples next. And then I want to look at how to manipulate fractions, and I want to do Euclid's algorithm. All right. Sort work. Okay, so on /temp fraction.class, this is a class file for a working fraction class. So you can grab a copy of that and then write some main programs and see what this should do, right, to get an idea for how your class should behave. Let's see, is there any way to write Java assembly code? I'm sure the creators of Java... I think so. I don't remember... I think I've actually stumbled across this not too long ago. A way to sort of directly inject bytecode, although maybe security-wise that's frowned on. I would guess that's available, but I don't know. Again, you could always like force it by making something that just cobbles together a class file on the fly and pulls that in. But that's a good question. Is there a way to sort of directly do inline assembly in Java? I don't know. eyeball it. I have your camera on my side screen, so I keep looking to the side when I'm talking to you. All right, so let's play around with this. All right, let's declare a pair of fractions. And somebody give me your favorite fraction. I can always count on you for good fractions. All right, there's a legit fraction. And we'll take the next one that came in, which is equally legit. Okay, we'll just have a fraction party. And of course, pi, thank you for that. All right, so there's some constructors. I'm on the server, aren't I? Hey, no syntax errors. Alright, so there we go. Well, that's disturbing. Sure enough. Thank you. Right, so what happened when I did that, right? I was constructing with a single argument. An integer division 3 over 13 is 0, so I constructed 0 over 1. Alright, so there's some fractions. And pretty remarkably, F1, that was already in simplest form. Yeah, no syntax errors. That's kind of strange. I know a bunch of us were using our cameras. Oh, cool. Nice. All right. So so we can do operations. So let's just subtract F1 from itself. All right, and so F1 minus F1 is 0. All right, so you know, you can use the sample main program from the assignment and run that against the fraction class, and that's a whole bunch of tests, right? There's lots of things you can test against in there, but you know, make your own test cases. You could make this, you know, driven from user input, so you can type in fractions and it'll give you some product difference, quotient repeatedly, and so on and so forth. But whatever you think makes sense, okay? And definitely test out, you know, division by 0, not a number, and test out negatives. And up here, let's just try one more thing. Right. Wow, those are still almost like relatively prime. All right. But, you know, should reduce things to simplest form. All right. So how do we do fractions, right? This is something we learn in school, but let's just do a quick refresher. Multiplication. Just multiply the tops, multiply the bottoms. So what does this look like in code? You write a multiply method. Okay, first of all, you make a class, and your fraction class has a numerator and a denominator. Okay. Now you write a multiply method. It takes an argument, which is a fraction. That fraction has a numerator and a denominator. What you want to do is you want to create a third fraction whose numerator is your numerator times the argument's numerator, and whose denominator is your denominator times the argument's denominator. So take those numerators, take those denominators, multiply them, create a new fraction. How do you do that? Call the constructor. New fraction, parentheses, you know, my num times argument num, comma, my denominator times argument denominator. And then that new fraction, you just return that. Return parentheses. Okay, you can do it in one line if you like, but you know, you can also break out, you know, a equals my numerator, c equals argument numerator, etc. Whatever makes sense to you. So multiplication is the most straightforward. Division is almost as straightforward. Multiply by the reciprocal. So this is a times d over b times c. And then the hardest of all is addition and subtraction. So put these things over a common denominator. So this will be AD plus or minus BC divided by BD. So not a whole lot of work you really have to do inside your methods. So normalizing. I'm like totally forgetting to tag stuff. All right, normalizing your fractions. Again, I suggest if you have something like this, change it to make the numerator negative. If you have something like this, change it to make both the numerator and denominator positive, right? Because these are equal. But now I can tell if I have a negative number by just looking at the numerator, right? Whereas here, right, doesn't tell me that it's negative. Here, it doesn't tell me that it's positive. So that's one normalization. If I have a fraction like 0 over 15, pretty easy to just change it to 0 over 1, right? They're the same thing, but now I know what a 0 looks like. That's optional. But division by 0, if I have a fraction like 15 over 0 or 0 over 0, it doesn't matter to me how you represent that internally, right? As long as when you convert it to a string it says NaN, when you convert it to a double it says NaN, and when you do any operations on this the result is NaN. Okay, those three things have to happen. You can set a flag in another field, you can look for a denominator of 0, it's up to you. Is normalizing a strict mathematical term or ambiguous? I don't think it's a strictly mathematical term. I'm using it in a very particular way here, which is just putting this thing in normal form. And normal form is another thing that mathematicians talk about a lot, but I'm meaning it more casually than that. Yeah, you're welcome. All right, so Euclid's algorithm. So suppose we have a fraction like 235/20ths, right? That may be in simplest form. It's actually not, right? There's a common denominator associated with this. How do I know? Because both of these are divisible by 5, right? That's my giveaway. But there may be a bigger common denominator as well, okay? So here's Euclid's algorithm for finding the GCD of two numbers. Take your first number, okay, and write it as 20 times something plus something. Okay, how many times does 20 go into 235? Well, it goes in 11 times. That gives us 220, and we have 15 left over. Now, move these numbers down and say 20 equals 15 times something plus something. Well, 15 goes in once, and it leaves us 5. And now bring these over and write 15 equals 5 times something plus something. Well, 15, 5 goes into it 3 times, and you have nothing left over. And so when you get down to a 0, this is your GCD. All right, so let's do that a few more times. Let's do. Hold on a second. Let me come up with a good number. Let's do GCD of 630 and 168. All right, so I want to write 630 equals 168 times something plus something. Okay, how do I find how many times 168 goes into 630? Just divide. And if you do integer division, it will automatically truncate. So 630 divided by 168 is 3. And to find the remainder, I can do percent. I don't think I can do percent here. Oh, I can. Okay. All right. Carry these over. 168 equals 126 times something plus something. Well, 126 only goes into 168 once. And the remainder is 42. All right, and then carry these over. 126 equals something times 42 plus something. So it looks like this goes in 3 times. And it looks like the remainder is 0. That wasn't superlicious. No, it was. All right, so there's a 0, so there's the GCD. So 630 divided by 42 is exactly 15, and 168 divided by 42 is exactly 4. So if this is my fraction, find the GCD, divide the top and the bottom by it, and you end up with the fraction 15/4, and that's in simplest form. Java with pointers, is that really a plus plus or is that a minus minus? And how come no one makes minus minus languages? We should invent C minus minus. We'll like take away I as a legal variable, but the rest of the language will be the same. All right, so that's Euclid's algorithm, and coding this is pretty straightforward. The reason this works is because whatever the greatest common divisor, whatever a common divisor is of 630 and 168, is also a common divisor of 168 and this remainder. Oh, someone did C minus minus. Oh well. Okay, so whatever is a factor of both of these things will also be a factor of the remainder. We'll do the reduced case in a second. That's a really good question. So GCD of A comma B is the same thing as GCD of B comma A modulo B. And A modulo B is always going to be something less than B, which means if we keep doing this calculation, eventually we'll get down to where the remainder is 0. And at that point, B will be our GCD. So you can code this recursively. Your base case is when B is 0, because you don't want to do a modulo 0, right? So you can play around with that. But I want you to code it yourself. I don't want you to just grab a GCD function from somewhere. This is like going to be an interview question for some student in this class, I suspect. That's just a prediction. At some point. So code that up, right? It's harmless fun when you're in between things, and then you can go ahead and use that. So what happens if we do this on numbers that are relatively prime? So GCD of I don't know, 101 and 23. So 101 equals 4 times 23 plus 9. 23 equals 2 times 9 plus 5. 9 equals 1 times 5 plus 4. 5 equals 1 times 4 plus 1. 4 equals 4 times 1 plus 0. There's your GCD. So if these numbers are relatively prime, certainly if they're both prime, the GCD will be 1, but 101 and 20 would still have a greatest common factor of 1. And you don't have to actually check for that, because if your GCD turns out to be 1, what are you going to do? Are you going to take your numerator and denominator and divide them both by 1? You're just going to end up with the same fraction that you had before. So most of this just kind of works without a whole lot of struggle. This, algorithm like this always starts off with the first number bigger, but if you were to switch this around, if you were to try to find the GCD of 23 and 101, what happens when you follow this? Well, you say 23 equals 0 times 101 plus 23 left over, and you carry these around, and now 101 equals 4 times 23 plus 9, and you're right back to where you were. The only thing that doesn't quite work well with this is if your numbers are negative. But if your numbers are negative, you don't want a negative GCD anyway, so find the GCD of the absolute value of the numerator and denominator, and then divide your actual numerator and denominator by that positive GCD, right? And that will leave your plus and minus signs the way that you're used to, and so on. All right, let's see. Yeah, we got a big C++, J++ conversation going. Let's see. 1997 C minus minus. Okay, so I'm too late for that. J++ was Microsoft's attempt. Yeah, that's okay. Yeah, I mean, we talk about this in 215, and you can find code in there, and so on and so forth, and you can find it in Discord too. But it's good fun to code it up. J++, yeah. All right. So questions about any of that? So I'm considering doing something going forward. I'm considering making Fridays kind of like an open lab. And I do this when we're in person. I haven't done this yet when we're in Zoom, but I'm thinking it might be useful to have Fridays, at least some Fridays, set aside for people to basically just come in and work on code and but have the class time dedicated to that on Fridays, so that you can share code with me, or we can debug it or stuff like that. Kind of what we do in office hours sometimes, but setting aside a class period for that. And this is kind of motivated because the other day when we were putting together rectangle classes, I noticed a lot of people were busy writing code and trying this stuff out, and syntax errors and things like that while we were lecturing. And so just kind of putting feelers out there. If you think that would be something that would be useful, something you'd like to take advantage of, give me a thumbs up or something, or pop a message in chat on the thoughts of doing like an open lab on Fridays. This is also something that you'll encounter at university level. Okay, so I'll think about that and look at schedules, and I'll definitely let people know through Canvas announcements and something in class next week. But I might try doing that going forward, or maybe I'll do it on Thursday since our assignment is due on Friday. All right, cool. That's all I got for today. I will let you out 60 seconds early. Yeah, I have my best questions. I'm working on something totally. So I want to take advantage of that. All right, enjoy the sunshine. Enjoy the weekend if you can. And I will see you on Monday. Thanks.